Hi everybody, today we're going to look at the sum and difference formulas extended. In this section, we want to apply the sum and difference formulas for sine and cosine to other trig functions. We're going to start by taking a look at tangent of alpha plus beta. Tan alpha plus beta can be written as the sine of alpha plus beta over the cosine of alpha plus beta. Taking a quick look back at our sum and difference formulas, we can see that the cosine of alpha plus beta is cosine of alpha, cosine of beta, minus sine alpha, sine beta, and the sine of alpha plus beta is sine alpha, cosine beta, plus cosine alpha, sine beta. Let's use those formulas to expand our ratio. The next part we're going to do is a big trick. We're looking at this big ratio and we're trying to make it a little bit more concise. So what we're going to do is we're going to divide each piece by cosine alpha, cosine beta. When I look at sine alpha cosine beta over cosine alpha cosine beta, I can see that I can cancel the cosine beta. Cosine alpha sine alpha over cosine alpha cosine beta lets me cancel the cosine alphas. In the denominator, cosine alpha cosine beta over cosine alpha cosine beta is just 1. When I look at sine alpha times sine beta over cosine alpha times cosine beta, I don't see anything that cancels. Our new reduced expression is sine alpha over cosine alpha plus sine beta over cosine beta over 1 minus sine alpha sine beta over cosine alpha cosine beta. Sine alpha over cosine alpha is equal to tangent of alpha. Sine beta over cosine beta is equal to tangent of beta. I'm keeping my 1 in the denominator, and then I notice sine alpha over cosine alpha is tangent of alpha, and sine beta over cosine beta is equal to tangent of beta. This gives us the sum formula for the tangent function. We could also develop the difference formula for the tangent function, but instead I'm just giving it to you on this page. The tangent of alpha minus beta would be the tangent of alpha minus the tangent of beta over 1 plus tan alpha times tan beta. Let's use that formula to find the exact value of tangent of 7 pi over 12. We'll start by using angles that we already know for the tangent function, pi over 6, pi over 4, pi over 3, and pi over 2. I'm going to convert all of these angles to a denominator of 12. That's going to make it easier to see which ones to combine to get 7 pi over 12. Pi over 6 will be 2 pi over 12, pi over 4 is 3 pi over 12, pi over 3 is 4 pi over 12, and pi over 2 is 6 pi over 12. Now looking at the angles, I can see that 3 pi over 12 and 4 pi over 12 is 7 pi over 12. That says I need to use pi over 4 and pi over 3 in my formula. I'll write that the tangent of 7 pi over 12 is equal to the tangent of pi over 4 plus pi over 3. Using the formula we just established, we can rewrite this as the tangent of pi over 4 plus the tangent of pi over 3 divided by 1 minus the tangent of pi over 4 times the tangent of pi over 3. Tangent of pi over 4 is 1. Tangent of pi over 3 is the square root of 3. In the denominator, I have 1 minus 1 times the square root of 3. Now that I have 1 plus the square root of 3 over 1 minus the square root of 3, I want to rationalize the denominator. To do that, I'm going to multiply by the conjugate, which is 1 plus the square root of 3 over 1 plus the square root of 3. Think like the difference of squares. 1 plus the square root of 3 times 1 plus the square root of 3 is 1 plus 2 times the square root of 3 plus 3. 1 minus the square root of 3 times 1 plus the square root of 3 gives me 1 minus 3. Let's combine like terms. In the numerator, 1 plus 3 gives me 4. So I have 4 plus 2 square root of 3. In the denominator, 1 minus 3 is negative 2. I can divide both terms in the numerator by negative 2. 4 over negative 2 gives me negative 2. 2 over the square root of 3 divided by negative 2 gives me negative the square root of 3. Our next problem says simplify the secant of t minus pi over 2. We're not going to come up with a difference formula for secant. We're just going to use that secant is 1 over cosine to do the expansion. Secant of t minus pi over 2 could be rewritten as 1 over cosine times t minus pi over 2. Using the difference formula for cosine, I have 1 over cosine t plus cosine pi over 2 plus sine t times sine pi over 2. The cosine of pi over 2 is 0, so cosine of t times 0 is going to be 0. The sine of pi over t is 1. 1 times sine of t will just be sine of t. My new expression is 1 over sine t, which I can write as cosecant of t. We will not establish sum and difference formulas for cosecant, secant, or cotangent. Instead, we will rely on our formulas for sine and cosine to help as needed.